everybody, Conboy here. You and I have an ambitious objective to meet, and that is to kick off the DNA structure function part of our unit by getting an overview of a field of research that is amazingly wide and incredibly deep at the same time. That is DNA research. It consumes billions of dollars per year. It is massive already, and it is growing at an exponential rate. In this presentation, I'm going to take a fair amount of time to explain some concepts. When I do, take good notes. If I spend more time explaining it, that means it's extra important and will be on the test. Other ideas, I might just refer to the diagram and encourage you to study it on your own just for the sake of interest. But you may not have to know that for the test. So keep that in mind as we go through this, because sometimes I'll be careful and sometimes I'll go fast. Now, if you're going to understand why DNA matters, you first have to know why a cell matters. Now, I know you all know that your body is made of trillions of cells and that those cells somehow cooperate, but I don't think everybody knows what each cell is responsible for doing. Essentially, you should think of a cell as like a factory. It's responsible for manufacturing a product from scratch. Now, cells, of course, are very tiny, so its products are all on the molecular level, pretty darn small. Now, if you want to understand a cell's basic job, then you should think about a factory's basic job and what that factory needs to succeed. That will help you remember how DNA fits into the cell. Let me show you. Of course, any factory, say one that's in charge of building cars, needs a power supply. In a cell, the power supply is ATP, which is a special type of molecule which we'll study in great depth later. But for now, you should just know that every cell ever studied in the history of biology uses ATP to power its activities. And in fact, viruses do not make ATP. They do not use ATP, and those are some of the reasons they're not considered alive. All factories have to use some kind of raw materials. To manufacture a car, you'd have to have a variety of metals and foams and rubber or plastic. In a cell, most commonly, we need amino acids. And amino acids, you might recall, we can get from our food by eating protein. Of course, a factory needs a variety of workers and a location to do their work, called the assembly line. Ribosomes provide both to the cell. Now, it would be pointless to spend lots of power and raw materials building something in a factory unless we had good instructions to guide us. In the cell, those instructions are provided by DNA and a similar genetic language called RNA. So, in order to understand anything in the rest of this presentation, you have to first understand that DNA and RNA are giving the cell guidance in how to build whatever it's supposed to build. So the cell has the same basic needs as a factory. I expect that you would understand the basics of a factory because our economy is so industrialized, and that can help you remember what's up with cells.